unconventional additives. So I'm sure this will be a little different perspective what you had from yesterday. So I was not knowing that my friend also will be giving a talk on this particular FBB. Otherwise, I would have changed the topic or I spoke with him. But unfortunately, yesterday only I came to know about his talk as well. Okay, anyway, so wherever you feel something is relevant, I think if at all you have some questions, queries related to the similar area, so even I'm happy to clarify some of the things. Okay, let's get into the talk what I have done and everything. So this is topic is completely like during my PhD work, but I IIT Bhubaneswar. So most of the work which I have done is relevant to the some of the two plants from Odisha. So I made the slides such a way that so most of the things you will be seeing are the characterization of red mud. So can sir, Dr. Chaitanya sir, just can you confirm like the entire screen is properly visible or there is some kind of wind disturbance? Because
Sir, yes, sir. It is coming, no problem, sir.
because I can see two windows are on my screen, so I'm using WebEx for the first time. So if it is okay,
Sir,
then
once again tell me, sir, actually your screen is visible, no problem, not issue. Now it is in introduction slide.
yeah, okay, perfect, sir. So like the red mud is one of the industrial byproduct like fly ash only. This is also comes from the alumina industry. Basically, you can see the generation of how much red mud it is. So basically, the bauxite is one of the main chief mineral. So once you extract some kind of alumina, the leftover product is called something red mud. Sometimes people also call it as bauxite residue. So both are interchangeable. Sometimes I might have used some of the words interchangeably. So basically, there are two types of processing methods. One is Bayes process, other one is sintered process. So both are completely different, and most of the Indian plants they are using Bayes process as of now. Sintered process is little difficult, different. So there you dispose the waste in the form of solid waste or dry residue. But in case of Bayes process, the disposal is in the form of a slurry, which includes more amount of water compared to the solid particles. Most probably the solid particles are in the range of 30 to 45%. Like I can say most of the time it is a slurry medium. So you can see like India is one of the largest alumina producer after China. So even we are as a growing nation, we need more amount of alumina as well. So this is a continuous process, or I can say the generation of red mud is inevitable unless until you don't have a bauxite in the India. So as long as there is a bauxite mineral, obviously there would be red mud. So we need to utilize how can we utilize this thing. So you can see some of the issues basically with red mud are some of the issues with red mud are like some of the catastrophic failures you can see in this particular slide. So which are not exactly with not only in India. So like Jharkhand, there was a recent red mud breach. Basically, whenever you have such kind of impoundments or disposal ponds, so obviously you need to have a proper embankment system. A failure of this embankment causes due to the excess bore water pressure or due to the toxicity as well. Sometimes there could be a bike embankment failure as well. So you can see some of the failures which I have listed here. Like Hungary, there was a huge catastrophe because of the failure of some kind of embankment. So even before India, there was China. So it is also caused some kind of inundation of entire whole village. Okay, this led to some kind of humans and problem to the animals as well. You can see there is another village which is basically from the China. So entirely the entire village got inundated. You can see. So this another one was some one of the recent study or incident which has happened in the Muri near the Jharkhand in Muri. So which is basically Hindalco plant. So where there was a impact assessment they have conducted, but somehow because of the red mud, so they said that there is no much damage to the surrounding. However, the major issue with red mud is these are highly alkaline in nature. So this is one of the issues, like what motivated to me study in this direction is that, so most of the, you can see, so storage needs vast fertile land. So becoming land is one of the important thing because our population is very high. At the same time, our land is very low. So once you are storing this kind of waste material, so we need to maintain them. It's not easy task, okay? And we need to continuously monitor what's happened to the failure systems. Like let's say if there is an embankment or other kind of structures, so we need to see what happening to the leachate and contamination of groundwater or soil as well. The main issue with red mud is, which is highly alkaline in nature. So most of the time you can see these are utilized in very minimal way, like in the form of a kind of admixtures, like some percentage, maybe hardly 5 to 10%, either to manufacture either kind of bricks or concrete. So sometimes people are also doing some kind of metal extraction, especially the red mud having high iron content. So people try to extract some kind of iron from the red mud as well. So there are some kind of rare earth metals as well. So they are also trying to, but if you see as a whole, the consumption is very less in the, like 5 points what I have listed in the second box. Okay, but whereas like fields, roads, embankments, there is a chance to utilize this material into, like in bulk volumes, I can say. So, but in the first five cases, it's only consumption of little bit amount of red mud. So we cannot use in the bulk way. But whereas like in roads, fields, embankment, we can use this material like in a bulk quantity. But at the time of my study, like it's almost when I started my PhD in 2015. At that time, there were very less studies. What people have done, including the kind of geotechnical characterization, are completely on the geoenvironmental characterization. So whenever you want to use any material, the characterization is one of the first and foremost important thing that you need to look at. So what I have done in my entire PhD work is like kind of extensive study on the geotechnical and geoenvironmental perspective, and moreover, I used some kind of unconventional additive, so that how can we improve the strength properties of a red mud so that we can use in the bulk quantity. So some of the issues with arises with red mud, or you can see, so most of the time the red mud has very low strength. So before using or any kind of, for any kind of applications, we need to improve the strength of material. Moreover, some of the papers what I have seen, they suggested that initially the red mud could be have some kind of collapse potential. So that's why, like, this is a one issue. Other one is dispersion. It act as a single grain particle, not as a clay kind of soil. Okay. So that's why, like, there could be a dispersion when it interact with the water as well. So at another side, there is something environmental issue, that is high alkalinity. So sometimes most of the papers, they say that you have to neutralize this red mud before utilization into different perspectives. So what motivated me is, like, you can see some of the issues, like not single issue. It's all about four different kinds of issues, like in the form of geotechnical environment I have presented here. So what I have done entirely in this work is, like, I have conducted whether can we use single additive to solve all these issues, or do we need any other material in combination with single additive, so that how can we eliminate some of the challenges which are encountered, like these multiple problems. So entire based on my and extensive literature and understanding, so during my PhD time, I made into, like, there are at least 5 to 6 objectives, but I have shown only 4 here, but I will be extensively discussing about the first, second, and the last objective. So influence of metal oxide I did not include here because uh, in this presentation, you can see first and foremost is that I have used some kind of different industrial waste or chemical additives, so that to see what happens to the alkalinity as well as red mud behavior, basically in the form of the geotechnical behavior. Like, I have studied, investigated. So, and I have also used some kind of unconventional, like polymer, like these are evolving in the last 5 6 years. People are talking about some kind of sustainable materials and carbon neutral materials, low carbon materials. So I have done some kind of study like how can we remediate uh, biopolymer dispersion characteristics using biopolymers. So ultimately, once I have done some kind of stabilization studies and utilization, so ultimately I have established some kind of geo-environmental characteristics to see whether these materials are suitable for any kind of applications or not. At the end, I think you'll love to see some of the slides. What I have made some kind of comparison with different codal provisions, whether the material is can be used before and after treatment or before after the stabilization. So the research methodology is divided into, you can see what I have taken. So I use RedMud and some of the conventional materials and unconventional materials, as said just now, some kind of low carbon materials as well. So in the form of conventional materials, like you can see some kind of GG based fly ash, like I have not included the results which I have done using fly ash because there was no much strength improvement in that direction. That's why I have not used those results. Like in my presentation, especially, I will be talking about GGBS and OPs. I think my friend Sharath also presented. I think I'm not sure exactly. I think he might have presented some slides on this direction as well. So better, I would be focusing more onto the characterization so that how the material behavior is, especially when it is added with the biopolymers and some kind of conventional materials. So we can see the entire methodology is divided like how we have done. So what kind of geotechnical properties I had conducted, and so coming to the leaching. So what is so I've not included slides which are related to particle settling. So the paper I have published in Indian Geotechnical Journal. So which talk about like what happens to the pH and what is the effect on the change in the pH environment, what happens to the particle settling and all. I have extensively presented those things, but I will show you some of the papers which I have published in this area. So those who are much interested, they can verify and they can write an email to me. You can contact me at any point of time. So I made some recommendations based on the geotechnical and geo-environmental characterization. So we can see like what are the from where I have collected two samples. So one is from the Vedanta. This is Langigar sample. So this is kind of a red mud pond. So you can see like how the red mud is simply getting dumped into the like Vedanta pond, and other one is near the from Nalco. This is present in the Koraput district in Damanjodi. So this is from Langigar. So here basically both of the plants are following the Bayes process only. But whereas I have been to the both sites to collect samples myself, and we have also done some kind of geotechnical investigation completely on the pond, so to see what's happening from the long time, what is the soil red mud characteristics and all. So, but I have not presented those things because that is we got some consultancy work from one of the company. So from the Vedanta, so I supposed not to disclose those results. And during my PhD, I worked with my professor. So those results I have not present here. Okay. So, but we have seen like how the characterization or settlement of particles with time, how what happens, what is the sample characterization. We have also done some kind of extensive study using AAS and ICP to see what are the different kind of metals present in the entire pond. So basically, this Vedanta plant, what they are doing is once you are simply dumping in the form of slurry, they are trying to remove the water in the form of a pressing system. Like they have some large compressing system, so that they're trying to remove the more liquid amount so that they can stack the red mud in the form of a dry cell. But it's not completely dry, but compared to slurry, like slurry, I said 30 to 40% of the solid particles present in the slurry. Whereas what they were doing is kind of practice is that they're trying to remove at least 50 to 60% of the water so that the soil red mud is more so that they can it won't occupy much amount of space. So that's they were doing. So this is simply like so what they do is once one pond getting dried, so they put some kind of fly ash over that, so that again they put continuously different layers of alternate layers of red mud. So I think this white patch you can see in the Damanjodi image is basically a kind of fly ash which is kept over the red mud. So let's see what are the basic characterization and what are the properties of each red mud and what is the classification. So you can see like both samples has almost similar specific gravity, like almost 3, because this is due to high amount of Fe2O3 content present in the red mud. Like obviously the iron has high specific gravity compared to any other element. Like liquid limit, you can see the range is like 40 volt. Other one is plastic limit is in the range of 29 to 36. But whereas you can see the plasticity index is low. Like if you make a comparison with any kind of clay soils, but even the particle size is in the range of, you can see like more amount of silt and clay, like 26%, 23% of clay and particles are there. But whereas the plastic index is lower compared to a kind of silty soils, like which are having a high, medium plasticity or high plasticity. So you can see the classification is something called silt of low plasticity, and moreover, both red mud samples has a pH around 11.2 to 11.9. Again, what I want to emphasize is it depends on the time of the sample collection, how much amount of time the samples are exposed to atmosphere. If you collect a fresh sample, obviously the pH of red mud will be more than 12.5 to 13. Basically, so there is something called carbonation effect. If what the soils are more exposed to the atmosphere due to the carbon dioxide which is present in atmosphere, the pH got reduced. There is a chemistry and a lot of people also done. So using carbon dioxide, the many people they had neutralized red mud so that it can be used for different applications as well. So you can see like silent features are like the red mud exhibits lower plasticity. It is similar to the clay properties, but as I said, these are not the particles are of the silt range, but these are not exactly silty soils. Okay, so and moreover, you can see from these graphs which are done some kind of XRD analysis. So these entire like this entire basically it's a bauxite ore. So these had different kind of iron related minerals which are basically very low or doesn't have any kind of clay type of mineral. That's what basically it is a kind of rock most of the time. The bauxite ore has some kind of iron ore metals related to iron ore metals. So you can see the comparison what I made with different literature as well. So the first two are like what I have done kind of oxide composition. You can see more in the Nalco red mud, the red Fe2O3 content is very high compared to the Manjori sample. But you can also see the amount of Al2O3, SiO2, how much it is. So there is, I think, people who are from the concrete background, they might be having a better idea whether the red mud is having a pozzolanic reactivity or not based on the chemical composition. Okay, so that's how we classify whether it is a class F fly ash or class C fly ash based on the chemical composition. So you can see like how the pozzolanic materials having like you can see the pozzolanic materials having a high amount of calcium oxide and followed by silica and aluminum. But whereas red mud has high amount of Fe2O3 content. So this is similar to other samples as well, which are collected from different places. Like you can see Indalco Raincoat. This is basically from UP. Other one is Indalmuri. So other one is this is present in the Belgaum, Karnataka state. So you can see consistently higher amount of Fe2O3 compared to the other elements. So you can see like Indian Nalco red mud has high amount of Fe2O3 compared to other plants. So you can see the basic characterization which I have done on the zeta potential. Basically, the zeta potential is a measure which shows the dispersity of the any metal. So basically, in paint industries, they use zeta potential is a kind of to measure and to maintain the quality of paints, like whether it is dispersive in nature, non-dispersive in nature. So most of the time they maintain a dispersivity like minus 40 millivolts something. So that would be a good metal, like if at all you want to have a better consistent paint system. I applied those kind of zeta potential. Like we had a zeta potential instrument to see like what's happening, and I changed the pH environment of the pore water. So like I have measured this pH, like one is in the range of 1:100 I have taken. So liquid to solid ratio. So for the liquid to solid ratio of 100, so I measured the zeta potential and found that with the change of pH environment, the zeta potential also changing. So you can see that PZC, this is called point of zero charge, that is something around pH 6.6. So it gives you some kind of indication that if at all you want to work on the red mud and if you want to stabilize or neutralize the red mud, so what would be the pH of the your pore water, so that you can reduce the pH of the red mud. So this is very useful, like people who work into the neutralization or stabilization of red mud. So even pH is one of the indicator how much amount of stabilizer is required to achieve the better mixing properties as well. Like people who are doing kind of rheology also, they can make some kind of correlation with the zeta potential. But I think in that area not explored, it will be a good research area. Like you can see for cements also, like if at all you are working some people, like you can have a kind of correlation. Like I'm not sure exactly, but I think this would be one of the good parameter to study, like slump cone test or to prepare any kind of geopolymers using a kind of zeta potential values. So those who have some kind of expertise on the characterization, they look into more into the details, so that they can have a kind of different area, so they work on. So as I was talking about the dispersion as well. So for the dispersion, like we have classified based on different testing. One is visual identification. This is basically a qualitative test. There is no quantitative test. So some ASTM standards has some kind of portal provisions as well. So to classify whether the soil is what kind of dispersion it is. So basically there are some ASTM standards to measure a double ground test. So double hydrometer. This is related to similar to the hydrometer test only. But in double hydrometer, what we do is, so I think I may have slide I will show you further. So I made into three different classifications. One is visual identification under the physical testing. So there is a crumb test. I will choose those results as well. The double hydrometer. These are basically, first one is a kind of qualitative test, but second and third are basically quantitative tests to measure what is the ratio of dispersion and how to classify the better, so that we can understand how much is the percentage of dispersion, so that based on that we can have a we can choose additives, what kind of additives would be better to stabilize this kind of industrial waste material. So you can see in this slide. So basically, this is a crumb test. What we have done is like I prepared a small cubes, like 2 centimeter by 2 centimeter samples. I kept them in the water, so that I continuously monitored for 6 hours. Then I was continuously seeing them like a kind of visual way. So what happens to the crumb? So with time, so it shows that the crumb which prepared, and you can see for the first 2 minutes is the dispersion is little, but whereas for 1 hour it is high. But being the particles are little denser, so even there was some kind of dispersion, but the particles got settled. There is a complete dispersion even after the 2 or 3 minutes. It shows that the red mud is highly dispersive in nature. So you can see other one is hydrometer test. So in the hydrometer test, what we do is basically, so one we do with using dispersing agent, other one is without dispersing agent. So after that, we make a comparison study, like let's say at particle D10, I want to set a D10, what is the percentage of final. Then I make a comparison, what is the difference between two. So this result shows that 85% of the particles are under the dispersion condition. It means that you don't need require a dispersing agent like sodium hexametaphosphate and sodium carbonate we use. So hydrometer analysis. It shows that even the without any kind of chemical, the red mud behaves a completely dispersive soil. So that this is highly dispersive in nature. So there is something called differential free swell index, the third one. So this is basically we do this testing for to characterize whether the soils are highly expansive in nature or not. So what I have done is, so you can see there are on the x-axis like kerosene, red mud 1, 2, 3. So basically these are a kind of pH values. Okay, so 1, 2, 3, 4. I have taken different values of pH. So that what happens, basically the liquid which is present in each cylinder is different pH. So then I have observed continuously or monitored for about 24 hours. Then what happens to the dispersion of this one. So ultimately we found that there is something called a negative swelling. So basically, if at all you are making any characterization of soil, you may see swelling of the soil. Like let's say if you are taken 10 grams of soil. So once it swells, it may be about in the 10 height of the soil is 10 centimeter. After swelling, it would be about 15 or 16. So that based on that, we classify whether it is highly expensive or not. But whereas in our condition, we observe that what the red mud, the taken red mud like lead sediment, that is getting dispersed into the soil, and solid particles are not exactly. Most of the solid particles are in the water itself. Like there is more dissolution of solids. So it shows that there is a negative dispersion. Like you can see the values using for a distilled water, it has a minus 27. So that we confirm that based on this study. So there is a dispersive in nature. These samples are like all these three physical parameters or physical tests which I have done clearly shows that red mud is a kind of dispersive material. So you can see the chemical analysis which I have done in the laboratory through some kind of titration methods and all. So we have determined the pH value. You can see clearly it is in the range of 10.5 to 11.2. So it depends on, again I said it depends on the age of the red mud that we have collected. So basically I had collected about from 3 to 4 different places. Okay, so the range was from 10.5 to 11.2. So I've also measured conductivity like on the same sample, like the liquid to solid ratio of 1:20. And we observed that this is a microsiemens per centimeter, so 1.18. So, and again, if you make we have also measured dissolved total dissolved solids, how much it is. Like it's you can see this is 16.81. So like once you have some kind of values, we can calculate what is the sodium absorption ratio, exchangeable sodium potassium, exchangeable this one. And I have seen this is the zeta potential is for the like the sample which is directly taken from the pond. So you can see, so what happens like the ranges I have given here for the SAR value and based on the electric conductivity. So the red mud clearly falls in the range of sodic soils. So sodic soils are kind of soils which are more dispersive in nature. So basically it has more amount of sodium ions compared to the like the normal soils which are like expensive soils and all. They may have more amount of calcium and magnesium. So they are better like they have better cohesion and there would be least dispersion. Whereas silty kind of soils are sodic soils, they have uh, more amount of sodium. They act as a kind of sodic soils and they get dispersed easily when it is interacted with the water. So based on this analysis, you can see so what is the total dissolved solids and yes percentage of sodium. So there are classifications are known. So you can see the present study is clearly falling in the range of a dispersive zone. So you can see zone A kind of dispersive, zone C is intermediate, another one is non-dispersive. Most of the soils which are expansive in nature, they may be not dispersive in nature. Okay, and other silty soils also some of the silty they may fall in this range, but whereas the red mud is highly dispersive in nature, it is clearly shows that all the visual identification, chemical and physical parameters, which clearly classify the red mud as highly dispersive in nature. So as I said, I had worked on the geotechnical properties as well. You can see some of the characterization which I have done. So I have included only few slides on the compaction characteristics, but I had extensively worked and published one paper on compaction itself. So those who are interested, they can refer to those papers. So the main point that what I want to emphasize is that, so even though I have used the same Proctor compaction test, so initially you can see there is a inconsistency in the results. Like most of the time, whenever we do any kind of testing, we do 2 or 3 tests, but we see that what is the like an average water content or OMC and MDD values. But whereas this red mud, you can see the MDD moisture content is OMC values are in the range of 30 to as broad as like about 45 also. So we observe there is some inconsistency, and this is also, there is a study done by one of the years of the, to study properly exactly what's happening. So they changed the different whether it is oven red or it is air red, and after treatment they observed it like what how the red mud behaves exactly. But I did not work onto the neutralization after that compaction characteristics. But so this is we observe that there is some kind of inconsistency because of the Proctor compaction test. But whereas like once you then after that what I have done is I have conducted some kind of modified Proctor to see whether there is a because of the application of energy, whether there is any but I interestingly found that you can see all the OMC values are in the same, like approximately similar, and at the same time MDD is also like maximum trade is also in the same similar range. But whereas for this entire samples this is very inconsistent. So this is because of the some kind of alkalinity. So I was not sure about that at the time. Like it was completely due to the amount of chemicals or alkalinity present in the red mud. So to establish this further, so what I have done is using compaction energy to change that. I have changed from number of those 15 to 46, so that these are from the from below the standard Proctor to the near modified Proctor, so that I have seen like initially you can see in there are about 5 to 6 curves in this range. So there was clear indication that till 45 number of those are energy. So there is no change in the either OMC or MDD. So the most of the time they were falling in this range only. But whereas with the increase of energy, I can see there is an increase in the maximum dietary density and reduction in the water content. It shows that the red mud is susceptible for like a kind of chemicals which are present in the red mud are more absorbing more energy, and it needs to like if at all you want to use this material in the field, so at least you need to go a minimum number of blows. Like you can calculate what is the energy needed for the 45 number of blows or 56 number of blows. So based on that we can apply in the field. So similarly, like again, as I said, there is a chemical composition because of the chemistry or alkalinity. So I try to establish then what happens, like if I use instead of distilled water or simple tap water, so I change the pore fluid in the form of a pH. Like I use pH 1, pH 1.2. So to study like what happens on the standard Proctor and as well as modified. But interestingly, there is no much change in the either AMC, MDD values, but there is a little change in the water content, that is basically OMC. But whereas in the modified Proctor, obviously there is a clear distinction between when I used NaCl solution, HCl solution of different pH values. So basically, NaCl I have taken in the form of molarity because it doesn't have any hydroxyl or other ions which impacts the pH value. But whereas HCl it impacts the pH value, so that's why I give the indication as in the form of pH value. For other things like I have taken molarity, so based on the amount of salt I have used. This is basically table salt which we use in the kitchen. So you can see the difference is clearly that there is excess water generation. So it occupies some of the pore water. That's why there is a high water content in this reaction. But whereas no chemical reaction in the whenever I'm using the NaCl, but it acts as a kind of lubricant to facilitate the better compaction properties. So I made a kind of analysis using different codal provisions. You can say IRC-SP28 to like different as to IRC mode codes and IRC 1948. Like so, the main use of these codes I want to make is that. So what are the minimum densities specified by each code? So whether the red mud is falling in these ranges. So can we use it as a kind of material? So you can see that ISSP 58 says that red mud, like most of the fly ash, they have the what dry density in the range of 9 to 16. Obviously, red mud is also falling, like you can see all the gamma D values. So they are in the range of 9 to 16, so that we can use this material for some of the applications as well. So OMC is also in the range of 18 to 38. So most of the time you can see water content, but in case of red mud, the OMC values are very high whenever you are going for opting for standard Proctor, so which doesn't give you high strength. So that's why when I was telling the practical applications, if at all you are going for modified Proctor, the density will be higher. At the same time, you have less water content and it leads to better shear strength value. So you can see how can we use red mud for different applications and the earth cover. So usually we need the density in this range. Subgrade, the most of the codes suggest that it should be 16.5 or 17.5 kg per meter cube. Like you can see some of the mode codes also says that minimum density required is should not be less than 14.6. This is for embankment, and whereas other one is for subgrade material. So basically the samples which are using a higher compaction energy in the form of a modified Proctor. So these values are excellently matching with the codal provisions. So you can see somehow I made a comparison study with other industrial waste or chemically treated soils as well. So you can see the bottom curves are related to like some kind of solid biosolid materials or in the form of solids or municipal solid waste. But whereas this 11 and 12 on the curve, we can see these are from the present study, so which are exactly falling in the range of either fly ash materials. You can see gerosite or different slag materials. Basically these are kind of inert materials, or I can say more related to silt and clay particles. So these are falling exactly in this range, so that red mud having a like almost similar properties to that of other solid waste as well. So further, like as I said, as I used different kinds of pH solutions as a pore water plate. So what happens to the consolidation, not only compaction. So I further made a kind of studies on the consolidation. I observed that there is no much change in the CC values. So you can see the ranges of CC are 0.01 to 0.1. So most of the silty soils have in this range. So these are exhibits, and this shows that the red mud is low compressibility characteristic. It means that in the long run, these are good compared to any kind of silty soils and soils. So you can see another comparative study that I made with another different fly ash materials are um, red mud samples which are available from the literature data. So you can see how the red mud results are like. You can see the CC values are in the range of, as I said, 0.081 to 8 to 0.1. But here you can see the UK sample, they are reporting it as 0.04, and fly ash also having a similar values 0.01, 0.15, 116 something. So even one of the Raipur fly ash material they are 0.04. Like I can say the consolidation behavior of the uh, red mud is similar to that of fly ash, which are available on the other sites as well. So they, moreover, they are good in the nature. So you can see, so the sample treated with HCl. So I made a comparative study with Newson, which is established. So you can see there is a similar behavior as well. Even after the acid treatment, there is no much change in the kind of consolidation curve. Okay. So I have also extensively worked on the stabilization. This is the one or two slides I want to emphasize is how the strength varies and what would be the minimum strength of red mud. You can see without any kind of addition of additives, and the hardly the strength of red mud is about 0. I can say like hardly 200 kPa or 0.2 MPa range. Once you add this material with the simple OPC, there is a change in the obviously because of the pozzolanic reactivity. So obviously there is strength in increase with the time, and as well as simple, like you can see another one is I have done alone with GGBS as well. There is an increase in the strength up to 3 MPa, but whereas using cement also up to 5%, so the strength is not more than 1.5 even after 90 days. But in combination with, you can observe like 15% GGBs plus OPC, there is an increase in the like almost 2 or 3 folds of this strength. Like you can say maximum strength up to even 4 MPa. But whereas in case of 5% OPC and 50, various percentage of GGBs, you can see when the strength can achieve up to 8%. So what we have taken is my intention is here. So I want to use more amount of waste materials and less amount of OPC. So you can see here more amount of, even though increase of cement is like 10%, 10%, 20%, there is no much change in the compressive strength values. Even after it is not more than 5 MPa. But whereas if I am opting either 5% or 25% of GGBs, most of the time the results are like we have better results as compared to 5% or 20% of the cement. So the main intention of this slide is so that how can we utilize the stabilized red mud as a kind of sub-base material or base material. So you can see some of the codal agencies or guidelines, transportation agencies, they suggest if it is a chemically treated soil. And so these values are for chemically treated soils. The range must be at least like 2 to 5 MPa. So obviously the results which I have presented here obviously matching the some of the guidelines are more than the superior to the guidelines. So even subgrade it's very low strength. Obviously these strength values are matching. So on the same samples, I have done some kind of XRD analysis. You can see there is no change in the 2D. Like I think people who are extensively working on XRD, they know what is 2D and intensity, these things. So I don't want to go into details. Like you can see the samples which are stabilized using red mud and GGBs, they form some kind of ringate structures, peaks, and you can see this. The bottom one is red mud, other one are stabilized with red mud using, red mud stabilized with GGBs as well as cement content. They clearly shows here some kind of ringate structure. So from the XRD analysis, we found that these are some kind of reactive products of KHR, CHS ringate. So which are prominent in the GGBs and cement stabilized red mud. So that these are the main primary primarily increases the strength. So you can see some of the XRD, some of the SEM analysis which are done on the GGBs and OPC stabilized soil sample. So here there is a clear distinct, this SEM image shows that there is a formation of wetering heads. So, and I made some kind of comparative study using the published data, so that these shows that some kind of wetering head formations on the red mud stabilized structures. Okay, so you can see some of the samples they are also forming honeycomb structures and ringate structures as well. So these are like if at all you are using higher amount of cement, there could be a possibility of honeycomb structures as well. That is may not be good for the stabilized soil. So as I was talking more into the treatment of red mud using the acids, like earlier I used HCl. So because HCl cannot be used in the practical application because of their highly acidic in nature. So there could be a possibility that we cannot use those acids in the application. So what I have done is we have collected some kind of organic acid that is called citric acid, and I prepared them in the form of molarity again, so that to see what happens to the consolidation properties. So it shows that even utilization of different acidic, even the utilization of citric acid, the CC values are well in the nature, but you can see the important thing here is that so if you are using excess amount of high amount of molarity of citric acid, there is some kind of breakage of bonds between the soil. So red mud, that is the reason why you can see the CC values are getting reduced. So it says that there is a breakage of soil-line bonds which are present in the red mud. So it suggests that we should not use the molarity of more than 1 molarity or 0.5 molarity, so that we can treat the red mud at the same time. There won't be any change of breakage of the structure as well, so that it won't contribute the more settlement. So basically, if at all you are treating the red mud with more amount of citric acid, 1 molarity something, so there would be more chance that the red mud collapse nature gets increased. So it is evident that from this graph you can see. So it shows that there is a change in void ratios where the even though if I had used the same amount of compaction effort like standard Proctor, other one is modified Proctor. Okay, so then after that I made a kind of you can see I have connected it because of you can see here what's happening. There is a decrease in the CC value, so that to understand exactly what's happening. So on the same examples, I have used collapse potential, so that we observed that so initially there was some kind of collapse in nature, but with the increase of uh, with the increase of molarity, there is a reduction in the collapse potential. So, but if at all you are using higher amount of acidic, like 6 molar citric acid, so it increasing or inducing the collapse potential. Is higher is the value, higher is the collapse potential. So you can see the degree of collapse like slide initially. So even though if I am using a 0.1 molarity or 0.5 molarity, there was a slight collapse potential. But if at all you are going for 1 molarity, 2 molarity, there is no collapse potential as well. So these are for the standard Proctor, and in the modified Proctor, so that is the reason why I mentioned earlier also. So better to use modified Proctor if at all this material is getting used in the field. So you can see, so higher is the compaction energy. At the same time, there is no collapse potential, even though if at all I am using till 4 molarity of the citric acid. But because of the breakage of the bonds, the collapse potential is getting increased because at the higher higher molarity of the citric acid. So this is one of the reason why. So even when you are treating any kind of red mud, so we need to monitor what's happening to the geotechnical properties. So this is basically like neutralization. After that, you want to use for any kind of applications, we need to see what's happening to the strength parameters. It's not about only strength. So what happens when it is interacted with another liquid medium? So we need to see it emphasizes that. So we always use better amount of or good amount of any kind of additive, so that in the form of a so for better application. So as I said, like I extensively worked on the dispersion. So I have used some kind of biopolymers because these are good in nature binding action. So because the binding action is not because of the hydrates and other thing. So they form a kind of hydrogel bonding and ionic bonding, so that they form a better thing. So basically, most of the time people say that this is some kind of environmentally benign material, because if you make a comparison with cement or any other kind of material, they are highly carbon intensive. But during the extraction or preparation of this one, so the carbon emissions are low or no carbon emissions. So these are some kind of people say like nowadays in the grouting applications also, instead of using cement, so people are using kind of biopolymers because these are also high viscous in nature. So they have good applications in the most of the applications. So let's see, like in continuation with the strength improvement. So what I have done is again using different dose of one. I have used two biopolymers. One is xanthangum, other one is gorgum. So gorgum is basically a kind of gaur beans. So, okay, based on the gaur beans, we can prepare a gorgum. So xanthangum is basically a bacterial process method. So which is produced using a xanthomose bacteria. Okay. So for improvement of the strength, you can see the biopolymer content of 0.5% is good enough. Like 1% is very good. But even with the increase of biopolymer content, the strength is also getting decreased. But at the same time, you can see the one of the main drawback with the use of biopolymer is that they are biodegradable in nature. So you can see like most of the strength like 25 days, 28 days, you can see all the peaks. But whereas for 45 and 90 days, you can see the reduction in the continuous reduction in the continuous reduction in the strength values. So this is why, like, if at all we are using anything for the short-term conditions or temporary applications, we can use them as a kind of stabilizing material so that we can. The good thing about this red mud is they remediate the dispersion very easily. So here the SEM image shows that this is not a trinket structure, but it's a kind of gel coating. As I said, they form a kind of hydrogel bond or ionic bond. So it depends on kind of biopolymer we are using. So again, so XRD analysis shows that there is no change of phase change basically. So this is simply a binding material. So you can see there is no change in the any of the two theta values, and at the same time here also there is no something. It's purely shows that the strength is basically improves based on the binding effect rather than the chemical reaction or phase change. So you can see in this slide how the red mud is the dispersion characters are remediated using a kind of crumb test. So basically, what I have done is the ASTM code suggests that we need to make a prepare a 2 by 2 centimeter by 2 centimeter cube. But whereas this modified crumb I prepared such a way that so we can also make cylinders so that we can see what happens to the shear dispersion of the soil. Even you can see in this picture clearly, even after the 6 hours of inundation continuously in the water, the samples are still intact. So this is for Gorgum, this is having a better dispersion remediation characteristics. However, so you can see here the Xanthangum samples which are getting collapsed easily, like even within the 6 hours span of the time. So that this is clear that so among these two, Gorgum has a better dispersion remediation characteristic compared to any of the compared to the Xanthangum. So this again I have done some kind of ACM study. It shows that similar kind of characteristics, and XRD also shows that there is no change in the phase. So to quantify this one, so you can see this earlier slide is a kind of qualitative study. So nowadays, if you at all you are doing any kind of qualitative study, people ask, or I always ask you, did you quantify something? So what I have done is to quantify this one. So simply I have taken the water from this sample, like you can see this raw red mud having some kind of more turbidity. So I have measured the turbidity, how much is the turbidity, like before the treatment and after that biopolymer treatment, what is the turbidity value. So you can see clearly. So I measured with the time. So you can see this dotted dark for the 6 hours, but 2 minutes, 60 minutes, and 120 minutes. So you can see like the sample immediately after the preparation, I kept in the water and I measured like this is initially the first sample. You can see that is at 0% is Gorgon. So it means that even after either at any time the turbidity is very high. It's more than like 100 to 1000, like more than 100, 10 to 100 in the range of 400, in the range of 10 to 400. But whereas you can see the soil stabilized with Gaurgam, you can see the most of the values are below 10 or just above the 10. So you can see there is a clear distinction in the turbidity values. Similarly, you can see in the Jantanam also, it has reduced the turbidity, but as a whole, the sample was not able to withstand it. You can see here, it is also clear that the turbidity values are getting reduced, but the sample is not properly intact. So that is one of the disadvantage with Jantanam. You can see the ranges was obviously it is less than 12 or something for all the samples. Here also it is about uh, uh, 7 to in the range of 12, all the turbidity values. So coming to the geo-environmental perspective, like I said, we have done a lot of geo-environmental characterization. So you can see first one is based on the complete acid digestion. EPA 3050 says that based on that I conducted on the red mud sample, we observed that except chromium, so most of the samples are within the hazardous levels. So here CPA says that, so these are the classifications. So except chromium, other all elements are within the permissible limits. So based on, there is another standard suggested by ASTM. This is simple water sake extraction, like 1:20 ratio we take, and after that extracted sample we have done, and it says that you can see like what are the drinking water limits, like US drinking standards. For chromium, it is high, lead, manganese, these are high, but obviously the red mud is not going to be used as a water treatment or any other kind of applications which are like more sensitive or more hazardous to the humans. Most of the time, what we want to use, how we want to use this material as a kind of construction material. So you can see there is a proposed manual by Tidley and SAG. This is that, so whatever the values are there, like you can take 100 times for the building material. So that he proposes his own kind of assessment. He says that these are the as per US drinking standards, but for building materials, these limits are allowable. So I can say this is we are not anyway. So obviously this is not going to be used as a drinking purpose or anything. But whereas as a kind of building material, obviously we can use the red mud. So just what I want to highlight is that even though this is not good for drinking purpose or it has some kind of negative drawbacks, but as a building material, even though this has high chromium or lead compared to the green standards, still we can use this material as a building application material. So you can see again, I have done some kind of TCL analysis. So again, so with the different molarities I have started, like I have done. So to see exactly what happens when there is a increase in the acidic content in the soil sample, so that we can see. So these are like, there is another code called RCRA. So which shows clearly like all the elements are within the limit. So this is for the one is treated with citric acid, the other one is stabilized soil on the stabilized treatment for GGBS and OPC. Basically, this sample is taken for different combinations to see exactly what's happening to the leaching of metals. Okay, so this is for the treated, other one is for the stabilized soil. So we can see clearly all the ranges, basically cadmium, chromium, and other metals, whatever the metals are there. So basically, where we are focusing, all are within the levels, like most of the values. So these are up on the 14 days and 28 days cured samples. So these results are far below the RCRA guidelines, so that I can safely recommend this kind of stabilized soils and as a kind of building application, not exactly building, like it can be a geotechnical, geomaterial application. Okay, so you can see like pre-treatment and post-treatment red mud with the different kinds of this thing. So I made a comparative study potential applications where it can be used. So dry density, so as I said, the different guidelines what I have shown some of the slides. So you can use this one pre-treatment, pro-treatment, so for all applications. So permeability, I have not shown the results, but permeability of the red mud is in the range of clay soil only. So it is 10 power minus 6 centimeters per second. So this can be used as a like structural fill material, so that will be good. But if at all you want to use this material as a kind of clay liner metals, so we need to use stabilized soil, and we can further reduce the vulnerability of this red mud so that we can use as a clay liner materials as well. So index property shows that these are like pre-treated may not be used, but post-treated are good fit after the treatment. So strength of the soil, as I said, the strength of the red mud is very low, like basically the 200 to 300 in the range. So pre-treated without any treatment, so these are not good for any applications. But obviously, once you stabilize the soil red mud, we can use for all the applications. Similarly, CBR also, like CBR of the, like I have not shown CBR results, but few CBR tests also have done. So low volume roads, we can use this. Basically, the CBR is in the 3 to 4 for the unstabilized red mud. So once you stabilize red mud, we can use for the different applications as well. So compressible I have shown. So without with treatment, without treatment, there is no much difference. But we need to see what about the collapse potential as well. So dispersion. So as I said, based on my study, so all three different studies, it shows that red mud is a highly dispersive soil. It needs to be treated, otherwise we cannot be used. Otherwise, some of the industries, what also they are doing, so they are constructing embankment and they are filling with different material as a kind of blanket material. So that is another kind of application. So we can use this as a kind of embankment, but it need to be properly covered with, so that there won't be any dispersion of particles as well. So that would be a good application. So I said, so pre-treatment, post-treatment, there is no like after post-treatment most of the time. So basically, if at all you are compacting the soil at modified proctor, there won't be much collapse potential. But again, the extensiveness of the treatment need to be. We need to see how much amount of treatment you are doing. So you can see other applications as part of different codes again I made. So what are the different available code, Indian codes and Western Australia code, US EPA guideline and all. So we can use this as a subgrade material, and for few applications that is subgrade. So of course embankment. So earth and cover also we can use obviously, but thing is they need to be covered with another waste material or any kind of natural soil as well. The low volume roads we can use, high volume roads certainly after stabilization. So as a building material, I have shown some of these requirements. I think for brick we use minimum strength required is about 2 MPa. The stabilized soil is about minimum of 2 MPa. So obviously we can kind of building material as well. Okay, so these are like what I have shown extensively, some of the conclusions and what I made from the study. So obviously these two beautiful tables show you like application point of view where we can use as a kind of material for different applications. So I don't want to go like in details about these conclusions and numbers, all the figures, how can we use, but ultimately I want to show you this one of the slide. So this is extensively covers all the materials what I have used during my study. So you can see like red mud is a kind of material. This is poorly put to fair for construction of embankments and subgrade. So without any stabilization. So compactability is also good to good. So again, we need to go for higher modified factor, slight to medium compressibility. So fade to poor drainage characteristics in the form of I would say permeability. Okay, so as I said, one single additive cannot make much impact on the stabilization characters of the red mud, but we can use 2 or 3 together so that we can uh, improve the strength of the red mud as well. But as I said, initially based on the chemical composition of red mud, so fly ash and GGBS, they don't improve the strength of the red mud much, but I have not shown those results because there was much no strength improvement even after 180 days of curing periods. So that's why I didn't keep those results. So, but whereas you can see GGBS, OPC, obviously there are some more pozzolanic materials, and obviously red mud doesn't have much pozzolanic reactivity. So that's why we need to have we need more cementitious material like OPC and GGBS. then only we can use them. But whereas biopolymers also increases strength, but it is because of the bonding nature, not the reaction or polyanic reactivity. So we can also use 1 molarity of citric acid so that we can make some kind of neutralization study. So biopolymers like 0.5% to 1% is good enough to do the strength as well as dispersion. So the final recommendation you can see is with 5% of OPC and 25% of GGBS, we can use for any kind of red mud stabilization. Okay, so these are some of the references, but I want to show you the journals which I have published from the entire thesis basically. So we can see some of the journals like Geotechnical Research, other one is published in Indian Geotechnical Journal. So one is Geotechnical Special Publication, which is published in ASCE. So other one is Geotechnical Letters. So those who are more interested about the settlement of the particles when they are exposed to different environmental conditions, they can refer to the paper which is published in the Indian Geotechnical Journal. So there I have shown some kind of zeta potential characteristics as well. So how the red mud particle settles based on the pore fluid whether by changing the pH values. Okay. So there are other publications as well, like which are published in AACE, and other one is based on Biomass Journal. So there is one more good journal like I have published extensively on the application of biopolymers to improve the strength characteristics. In this paper, like I made some kind of literature review along with that I validated with a statistical analysis as well. So those who are interested much into the biopolymers for building materials, they can refer. This is one of the good paper, which is published in Environmental Geotechnics. So these are like a kind of more collaborative work with my juniors, and so like I had initiated the work, and my juniors also like they work in one different aspects like what happens to more about the environmental properties when they are using or utilizing with different additives. So like some of the proceedings, book chapters, you can refer these things as well. Like you can obviously contact me anytime. I will drop you my email ID. If you have any doubts, you can contact me at any point of the time. So with this slide, I would like to end the presentation. Thank you. If there are any questions, we can take up maybe 10 to 15 minutes. Chaitanya sir. Chaitanya sir.
Sir?
Yes sir. So
Please.
if any comments in the chat box, or if someone has any questions, they can unmute themselves, like they can ask me any doubts or questions.
Hello everyone, you may ask your questions, ma'am.
Yes ma'am, please. Any questions?
Sir, I think there are no questions. Let's wind up the session, sir.
Yep, just I will drop my email ID. Someone has any queries in the future, that feel free to email me.
Okay, sir. Thank you, sir, for your extensive knowledge and pioneering work in this critical area of research. Your in-depth analysis and innovative approaches to tackling the challenges posed by a bauxite residue have shed new light on this important issue. This is my distinct honor to extend our heartfelt gratitude to you, sir, for your enlightening presentation on characterization and stabilization of bauxite residue that is commonly called as red mud for sustainable geotechs. As a part of our faculty development, The strategies you have discussed for the stabilization and utilization of red mud in geotechnical applications provide a clear path toward environmental sustainability and economic efficiency. Once again, sir, on behalf of our KL University Department of Civil Engineering, thank you for your valuable contribution to our program, sir.
Thank you, ma'am. Thank you, Dr. Chaitanya, for inviting me for the excellent DP.
Yes, you may leave now, sir.
Yeah, thank you, ma'am.
And I request everyone to fill the feedback form that will be provided in chat box.